All right, on the paper, you're going to write. You're going to write solving rational equations. Solving rational equations. I didn't say it before, but you might want another color, so if you want to go back and grab a marker or a colored pencil.
It's got to be pink. And why are you wearing so much gray? Yeah, that makes sense. I should call you grass.
So the first thing we're going to do is we're going to figure out what the common denominator is. So anyone want to share? 2n. Okay, so I'm going to say my common denominator is 2n. And then what we're going to do is we're going to take, I'm going to go ahead and write the equation again because these are my notes and I don't want to write all over the original problem and then be confused later. So I'm going to go ahead and just write this again, but when you're doing this for practice problems, you won't have to write it twice. And what I'm going to do is I'm going to take the entire equation and I'm going to multiply it by 2n. And the reason I can do that is because I'm multiplying the left side of the equation and the right side. So it's going to keep the equation balanced because I'm doing it to the entire equation, left side and right side. Okay, so I'm going to take this 2n and I'm going to distribute it to everything. So I'm going to say times 2n over 1 times 2n over 1 times 2n over 1. So what's going to happen is this n and this n are going to cancel. What does this remind you of?
The imaginary fractions.
Complex fractions, right?
Yeah.
It should remind you of complex fractions. And then for this one, the 2n and the 2n cancel, and that leaves us with just n minus 4. And then for this one, the 2 and the 2 are going to cancel, and it's just going to leave you with n. This is not the only way to solve an equation. The reason I'm teaching you guys to do it this way is because it's a little bit easier to do it quickly if you do it this way. And so I'm teaching you guys the quicker way for things since you were in the advanced class, and some of you guys are going to go on to classes like pre-calc and calculus. Okay, so sometimes we want to be efficient if we're doing really long problems. Okay, what should I do now? Distribute the 2. So I'm going to have 8n plus 48 plus n minus 4 equals n. So 9n plus 44 equals n. So, okay. Okay.
Oh wait, no, that was a stupid question.
All right, so if we simplify the top and the bottom, so n equals negative 11 over 2, and we are done. Okay. Now, if we look back at the original problem, when we solve equations, there's one little extra step we have to do, and we just have to start at the very beginning. We have to say what our excluded value is. So if we go all the way back up to the beginning, n cannot equal 0. And then we take that excluded value and we compare it with the answer, and we just make sure that the answer is not the excluded value. As long as the answer is not the excluded value, you're good. And I'd say most of the time it's not the excluded value. Every so often it is. Then you would say no solution. So if we had solved this and we got 0 as the answer, and 0 is like the one number you're not allowed to plug in, then we'd say, oh, that problem did not have an answer. Because 0 would make the denominator 0. 2 times 0, that denominator would be an issue. 0 down here would be an issue. Okay. All right, let's try another one. Example 2. So for this one, we're going to say 1 plus 1 over r minus 1 equals 4 over r minus 1. So our common denominator would be what? And r cannot equal 1. Okay. So we're going to take the entire equation and we're going to multiply it by what? R minus 1. Okay. So when I take the r minus 1 and multiply it by the first term, what happens? The first term? It's just r minus 1, right? When I take the r minus 1 and multiply it by the second term, what happens? They cancel and I would just get 1 plus 1. When I take the r minus 1 and multiply it by the last term, what do I get? Just cancel, they get 4. Okay, and does that make a difference with our excluded value? It doesn't matter. The excluded value didn't tell us anything about it, right? Okay. All right, let's try another one. Example 3. So this one is n minus 6 over n plus 2n plus 4 over n plus 6. No! Come on. Come on. I did this in calculus too, but in calculus it never came back. Okay, so for this one, the common denominator is n times n plus 6, because the denominator, right? And our excluded values, we cannot have, you're close, -6, all right? And so what we're going to do is we're going to take the equation and we're going to multiply the whole thing by n times n plus 6. Did it confuse anyone when I didn't write it this time? We did the canceling in our heads. Was that okay? That sounded like you were going to throw up. I was ready to do it. Like, if you were going to dry heave, I was going to dry heave. It was going to happen together. All right, so if we multiply that by the first term, what's going to happen? Yeah, the n's are going to cancel, but we're still going to have the n plus 6. So the n minus 6 from the term itself is going to be there. The n cancels from what I distributed, but the n plus 6 is still going to be there. Okay. Then when I take this and multiply it by the second term, what happens? The n plus 6's are going to cancel, but the n is going to stay. Yeah, I'm going to go ahead and write it just so I can be careful. I don't like to do too much work in my head because that's when I make mistakes. All right, and then when I multiply it by the 4, what happens? Yeah, nothing cancels, we get the whole thing. Okay, so when we FOIL this, what do we get?
N squared minus 36.
Right, that's difference of squares, okay, plus
2n squared plus 1.
equals
4n squared plus 24n.
Okay, so this one is a little bit more complicated than that last equation. A little bit, just a smidge. So we have to combine like terms. Yes. So we have 3n squared plus 4n minus 36 equals 4n squared plus 24n. Sorry, don't forget that n. Okay. So yeah, so since this is where the n squared is the biggest, we're going to take everything and move it to the right. This right here?
Oh gosh, I didn't write that.
All right, so we have 4n squared minus 3n squared is just n squared. 24n, I have the 4n and I'm taking it away, so that's plus 20n. And then 36, I'm adding it to the other side. So two numbers that multiply to 36, but add to 20. (18 and 2). N plus 18. N plus 2. You guys aren't used to numbers as big as 18 being a factor. Yeah. All right, so n equals
Negative 18 and negative. Wait, how?
negative 18, negative 2. And are we concerned about either of those based on our excluded values? Nope, they're both good. They were 0 and negative 6, and so we weren't worried about it. Okay, let's try another example. Example 4. Yeah, this is the original equation. No, I have these written down. Would you be more impressed if I said I was making it up on the fly?
Yes.
I was coming up with it right now.
What if the answers?
Then you could say there's no solution. It happens sometimes. Or maybe it's a problem like this one where you have two answers and one of them is excluded and then the other one is the only one that works. So yeah, well, you wouldn't say half no solution, you would just say instead of having two answers it just had one. Yeah. If your answer is one of them. So if we had gotten negative 6 for an answer on this, then we would have said negative 6 can't be the answer. Yeah. Okay, so before we do this problem, we need to see what those denominators are, because those denominators look like they're all different, and the common denominator is not like all three of these separately. That would be terrible. That would be like the worst problem of all time. So this is actually m times 3m. No! No! So, anyone want to say what they think the common denominator should be?
4n, 3n.
4m times 3m minus 1. Okay. So, I'm going to go ahead and when I rewrite the problem, I'm going to write the denominators in that factored form because it's going to be a little bit easier to think about if we do that. Yeah. Okay. So, oh, and we can find our excluded values. M cannot equal 0 or 1/3. Okay. So M cannot be 0, it cannot be 1/3. Okay, so if we take this and multiply it by that one, the M's are going to cancel, the 3 M's minus 1 are going to cancel, the 4 is not. So I have to keep the 4 and the M minus 1. Okay. When I do the next one, what's going to cancel and what am I going to need? Yes. So you're going to say, like, the parentheses completely cancel, right? And then you're going to say 4M divided by 2M is 2. So we're going to have the 1 that was there and we're multiplying it by a 2. And then with the last one, it completely cancels, M squared minus M minus 12. So even though those denominators all looked kind of crazy, that problem was about the same level of difficulty as the one before. You just had to be careful with the denominators. Okay, so we have 4M minus 4 minus 2. So 4M minus 6. And then what should I do? Move it all over to the right side. So M squared, if I have a negative M and I move the 4M, what do I get? If I have negative 12 and I move the negative 6. Negative 6? Yep, negative 12 plus 6 is negative 6. Okay. So we are multiplying to negative 6, but adding to negative 5. And M equals, okay. And based on the excluded values, we're all good. Yeah, those are good answers.
Oh.
Nice job making them up, Ms. Rice.
Oh, thank you, thank you. Should take it off. I think that's good, probably. I think that's good. Do you feel like that's good? Do you guys want, do you want another example or do you feel okay with that?
We really don't care.
Do we feel good about that? Yes? Okay.
Well, I won't